Welcome to part 2 of this video. Now that we have graphed a log function, we're going to see what happens when there are transformations that are in place. So you have your basic parent function, y equals log base b of x. The general should look very similar to the other kinds of transformations that we've seen when we did parabolas and radicals. A does what it always does. If it's between 0 and 1, it's going to compress it. If it's negative, it's going to reflect it. If it's bigger than 1, it's going to stretch it. Your x still lies to you. X moves things left and right, and so if you see a +3, it's really going to go to the left 3. The k does what it always does. It moves functions up and down. So we're going to take our basic parent function, y equals log base 3 of x. So I kept the exponential form. Now I've added to it. So now I have a function with some transformations. So I have my basic parent right there. That part stays the same. But now I have x minus 2. So your x lies. So this went to the right 2. And then that plus 6 means that it went up 6. So here's how I generally teach it. You take your parent table of values and you apply the transformations to make a new table of values. So if x went right 2, we're going to take all of our x values and we're going to go through and we're going to add 2 to them. My function went up 6, and so moving up and down is something that y does, and so we're going to take all of our y values and we're going to add 6 to them. So then I would come over here and I would do the math. So 2 plus 1/9, 2 1/9, 2 1/3, 3, 5, 11. Now do the math on the y. -2 plus 6 is 4, 5, 6, 7, 8. So I left my parent function on here. So what all of these points are going to do is going to take each one of them and shift them right 2 and up 6. 2, 3, 4, 5, 6, 7, 8. So this original point, it's going to go right to 1, 2, 3, 4, 5, 6. This point that was at 1/3, -1, it's going to go to the right 2, and it's going to go up 6, so that puts it at the 5. And then we have the point 3, 6, 5, 7, 4, 5, 7. So since you had your old asymptote right here at x equals 0, now since we just shifted everything to the right 2, that also shifts your asymptote. So we have a new asymptote at x equals 2. So then if we went through and connected the dots, your new graph would look something like this. So everything just went to the right 2 and up 6. let's say that we have a function such as y equals 3 times log base 4 to the x minus 7 minus 9. If I asked you to state all of the transformations from the parent, you would need to go through and figure out, all right, so that is my basic parent right there. That 3 is your a, so your function will have stretched 3. This is your h, and your x always lies, so that went to the right 7. And that's your k, and so the function went down 9. Hope this helps with how you apply transformations to logs.